Perfect. Thank you everyone for inviting me here. My name is Louis Moreau. I lead the developer relation team with Edgeimpulse. I'll go a bit more in details of what we do at Edgeimpulse in a few slides. I started my career connecting rhinoceroses in Africa. So I developed a small GPS tracker with some conservationists, rangers, scientists, basically to track the rhinos in a Zimbabwean conservancy. So that was a fun project. I've been working on earthquake monitoring in Mexico. Many fun projects, including hardware, high tech. A couple of years later, I went to the cloud environment, and now I'm mostly in AI. But back to my IoT passion, Edge AI is still combining IoT and AI. So the talk for today is AI at the edge, the next big thing for your company. We've heard the word AI, especially since a year and a half, 2 years, with the launch of ChatGPT. But what do you really know about artificial intelligence? Maybe some of you already use it for work or not, we'll see. AI, artificial intelligence is a huge, it's a huge domain. There are so many different techniques. ChatGPT, as you can see, it's only the red bubble in the middle of it. It's part of the transformers, and the transformers, it's part of the deep neural network and neural networks in general. So Edge AI is another subcategory that includes a bit of all of that. The particularity of Edge AI is its capability to run on edge devices. What I mean by edge devices is embedded device or microcontrollers, Linux-based gateways. I'm not going to enter more into the technical part, but for example, I saw Chris, you have the Aura ring. Aura used to be one of our customers. So basically all the intelligence is inside that microcontroller. So it detects sleep patterns. So how from a human signal, in that case temperature, movement, and PPG, so your heartbeats, it can detect your sleep stage. Are you in a deep sleep mode, are you in a light sleep mode, or are you fully awake?
Sorry to interrupt, is that anything to do with Microsoft Edge? Or is that...
No, that's definitely not, well. Edge is no, that's a good question. When you say running models on the edge, usually it means running not into the clouds, but in the far edge. It could be a smartphone, it could be like a ring, or it could be like an industrial machine. And I'm going to come back to that. So why Edge AI matter? In AI, in general, so this is, I've seen loads of progress in AI. One of the constraints is if you have, for example, a camera that tries to sense what is going on around the camera, it needs to capture the frame, then send it to a remote server, then the AI will process it and then send back the information. So you have a lot of latency, which can be super dangerous, for example, on autonomous cars. The cars need to take decision in a fraction of milliseconds, or in a fraction of seconds. If you can process the information right at the source of the data, you save a lot of time. You save bandwidth as well, because sending data to the cloud is costful. You need a 5G connection if you want a high stream. I'll come back to the cost later. It also brings the possibility of running AI models where you don't have any internet connection. Let's say, for example, you've got an oil rig in the middle of nowhere. You don't necessarily have internet connection. I know Starlink can now kind of cover that, but still, you still need a satellite connection. So a couple of use cases that we work with our customers. Where is my pallet? So how can you detect from a pallet using just a motion sensor if a pallet is in a truck, if it's on a forklift, if it's laying or in an idle state in a warehouse. So this is a use case from one of our customers. Advantech, how can you increase the productivity on a production line? So how can you see a defect that goes in a conveyor belt or a production line? And as soon as you see the defect, you can either stop the machine but keep the other part moving on, try to fix it as soon as possible. So here that customer got a big ROI, return on investment in using Edge AI models. Those are, the two first one are more industrial. Here it's something that we love. It's all things related to healthcare. So we are not FDA approved as a Food, Drug and Administration. So these take a lot of time to get the approval and the licenses. NoLab, it's a device that does non-intrusive glucose monitoring for people who has diabetes. So instead of getting a blood drip from you, it can just by analyzing the flux of the blood predicts some metrics. Another one is Hive. It does coughing detection. So this one actually it got a lot of money from post-COVID. But they have got a huge model, and using Edge AI and especially Edge Impulse, my company, they managed to increase the accuracy and reduce the model size so it can actually fit into devices. We love AI for good projects, so we partnered with Conservation X Lab to build like a camera trap that can detect different species, their behavior, identification of individuals. So we sponsor many like Edge AI for good projects. We're part of the 1% for the Planet consortium, where 1% of our revenue goes to non-profits cause that we as an employees vote for. So that's a good thing. Now, how it works, Edge AI? AI in general, there is a kind of a shift in paradigm. The traditional way of writing programs is you have some data, you write some rules. So basically, if the temperature is above 21 degrees or 25 degrees, let's turn on the AC. That's super easy. You definitely don't need AI to do that. But you write the rules by yourself. The way machine learning works is you take the data and all of data that can be representative to your problem, and then you let a model learn the rules by itself. When it comes to the inference or running the prediction, it's the same. Basically, the program that you wrote, the AI will come up with a model. So in the end, you pass some data, and on the output, you'll get some actions or some prediction. One thing is it's non-deterministic. So it's all about probability. So it can never be 100% true because it has learned on the data. And when you pass a data that has been unseen, obviously the model will try to guess what it is. So it's all about probability. Now, in embedded machine learning, we have the chance of having the device in the field. So you have a device, you collect some data, usually collect them from the device, but not only. Then you design a bit, you create your, we call that an impulse, but it's a mix of between digital signal processing and machine learning model. You test your model to make sure it will work accordingly on real use cases, and then you deploy it back to the device. So you can go to that active learning loop. However, it might be a bit tricky. This is probably the most complicated slide. So let's take the example of the raw audio signal. If you say, here it's a yes, I'm actually not sure if it's a yes, checking at the raw data. Then you convert that into a spectrogram. This will ease the raw feature or the feature that you will pass to the neural network to learn. Then you pass that to a neural network, and then you make some prediction. Is it a yes, no, on, off, whatever? That can be complicated to create everything together. So we, as Edge Impulse, we developed a platform, especially to cover the Edge AI use cases. So we are pretty big in the space. I'd say we're definitely one of the key leaders in the industry of Edge AI. We have 160,000 developers on our platform. My goal for the end of the year is to reach 500,000 developers. So I've got a big focus in user growth or developer growth, create awareness. That's part of my job. I love giving talk conferences, etc. We have more than 400,000 developer projects and enterprise projects. Not all of them are paying customers, but still we work with key leaders in the industry, Polycom, Hive, Care Products, Neurable. They do like a headset that do ECG on the headset to detect like stress and concentration levels. So yeah, many super fun use cases and cool. We work with any hardware, meaning like if you want to deploy your device, your model onto a device, we work with you. We work with all those partners to make sure our models will run efficiently on edge devices, including leveraging hardware acceleration. I'm not going to enter too much into details, but our models are top performing on edge devices. So that's our key strength. My two co-founders are ex-employees of ARM, which design chip infrastructures or chip architectures. So they know all about like how to leverage like hardware acceleration, and this is key. Now, we've been speaking about Gen AI, so LLM stuff, ChatGPT, what it has to do with Edge AI. How can we leverage that? Because Gen AI is everywhere, and this is kind of the cool kid in industry, I have to say. You can have fun with it, you can create some really cool project, and there is some business value. So first thing is synthetic data. So data is cheap, but labeled data and quality data is extremely expensive to collect. One thing that you can do with generative AI is to create synthetic data, meaning like if a data is too expensive to collect, let's just synthetically create it or use it to supplement your data set. You still need some real data to make sure your model will work. I've got
Have you ever tried to collect the datasets from sounds that are hard to catch? To help us improve the quality of our sound dataset, I've been working on an integration between Edge Impulse and ElevenLabs.io. Edge Impulse excels in the creation and optimization of Edge AI models, while ElevenLabs offer advanced capabilities to create realistic sound effects. This is particularly useful in scenarios where high-quality data, diverse training data is scarce or expensive to collect.
I'm not going to go through the whole video, but yeah, collecting the sound of a glass breaking, like if you need 10,000 samples, it means you need to go to IKEA and buy 10,000 glasses, like record them and then clean the floor. So yeah, so I worked on an integration with a synthetic or with a AI company that does mostly like sound and noise creation or feature extraction as well, like how to transcribe what you're saying. So they are a key player in industry. So you can use those techniques to synthetically create some data. Knowledge distillation. This is a super interesting topic. So those extremely large model that requires a lot of compute, a lot of energy to run, they are extremely powerful. So you can just send an image and it will give you the context, etc. Now, in most Edge AI use cases, the scope is heavily constrained. Let's say you only have a camera on a conveyor belt and just check a defect in manufactured PCs. You don't want to use a LLM that has this immense knowledge. You just want to take a small portion of it to train a model that is way smaller and constrained to that use case. So in that case, you can use a large AI model. So we call that the teacher model and use its knowledge to label, so AI labeling, or use AI to label the data, and then train a smaller model that can run on edge devices. Checking quickly at the time.
If you manage large datasets, especially with image, audio, or even bounding boxes, AI labeling can save you a lot of time by automating much of the labeling work. We pre-packaged for you several pre-built AI labeling blocks, like the old VIT model for object detection, a series of GPT-4o blocks for image and bounding box relabeling. Each of those blocks are hosted on GitHub. Feel free to have a look. The configuration process is pretty simple. You can start by going to the data acquisition section and then go to the AI labeling tab, select your block and fill the configuration. We have a preview button, which is pretty handy to make sure your prompt and configuration are correct. And then once you're happy with it, you can add a few metadata and label your whole data set. Note that you can chain also several AI labeling blocks together, such as if you want to use the old VIT to first detect object in an image and then use the GPT-4o to relabel. So you can go into complex data pipelines or data labeling pipelines. In conclusion, you can set different labeling actions. You can choose models, customize your prompts or your parameters. You can define filters for each actions to tailor the labeling of your need.
Yeah, so basically labeling data is extremely complex, but if you use large language models and you create pipelines to step that, it's super powerful and you can go way quicker. I have labeled myself like 10,000s of images or audio signal, etc. Wow, that saved me a lot of time, so I can focus on tasks that are much more valuable.
If you manage large data set.
And then there is another thing is what about a hybrid version of Edge AI and Gen AI or large language models? So running a large language model full time is super expensive. The inference cost is only 0.02 cents or even 0.002 cents per inference, considering like a kind of a square image. But if you want to run that at 1 frame per second, like for the full day, let's say for a security camera, if you take that price for 1 FPS at 60 seconds, 60 minutes, 24 hours a day, that will cost you $172 per day. So you probably don't need to run the inference all the time on this. You can put them together, and especially if your use case is highly scoped, you can get the same accuracy on your use case while saving bandwidth and a lot of cost. So that's kind of an example. So here is a high resolution camera. You can run the inference, so detects where are the objects in the image. You can then extract the objects and then run an anomaly detection mode. All of the left part is running on the device. And then if you have an anomaly, you can create a prompt. For example, only a cube should be visible. Can you explain the anomaly? Here in that case, the response is a capsule is present on the cube. So you can take the best of both worlds, saving a lot of money and still get the accurate results. Two of my co-workers, including Jenny in my team, wrote a book, AI at the Edge. I created a QR code, so if you want, I get the free ebook. Feel free, and I'm done with it. If you have any questions, I would be super happy to help you answer your questions, etc.